Okay, so on the last set of notes we did, we were expanding, we were multiplying, we were distributing. Now we are going to reverse all of that in a method known as factoring. So the first examples we'll start out with is finding the greatest common factor. So the definition of a greatest common factor is the greatest factor common to each integer or each term. So it is the largest number that divides evenly into all the integers or terms that we are given. When factoring out the greatest common factor in polynomials, we look for the largest number they share as well as the most of each shared variable. So basically, we're looking for common terms. So like I said, on the last set of notes, we were distributing. So we had A times B plus C. So if I distribute that A, we get A times B plus A times C. But now we're going to take AB plus AC and reverse the process. So we're going to take AB plus AC, and we see that it has a greatest common factor of A, which will give me the factored form of A times B plus C. So we are reversing the distributing process by finding a greatest common factor. Okay, so let's get started. Okay, so factor out the greatest common factor. So when we look for our GCF, the first thing we want to look at is our numbers. So here I have 3, and here is I have 15. What is the factor, or what is the number that 3 and 15 have in common? Or I guess I could say, what is the
3.
smallest number they have in common? Good, 3. So what we're going to do is factor a 3 out. So I'm going to take a 3 out. And when you factor, you are essentially dividing it from every term. So if I take 3 from 3q, what is left over?
Q.
Q. Good. Minus, and if I take 3 from 15, if I factor 3 from 15, what am I left with?
5.
5. That's it. We have factored that expression. And the way to check your work is, well, just distribute it back. If I said 3 times q, I get 3q minus 3 times -5, -15, which gets us back to the original problem. So that's how you check your work. Just distribute it back to make sure you have it right. Okay. Next, 2. 5c squared minus 10c plus 15. So again, look at the numbers first. I have 5, 10, 15. What is the smallest number they have in common?
5.
5. So we're going to factor a 5 out. So if I take 5 from 5c squared, what's left over?
C squared.
C squared. Minus, and now if I factor 5 from 10c, what's left over?
-2c.
Good. Plus 5 factored from 15 is
3.
3.
Yes.
That's it. Nothing else we can do there. And again, check your work. Make sure it's good. 5 times c squared is 5c squared. 5 times -2c is -10c. And 5 times 3 is 15. So it all checks out. All right. Everybody good so far? Okay. So now 3. T to the 4th minus 4t plus 8t squared. So I always say look at the numbers first. So we know that if there is no number shown in front of your variable, it's understood to be 1. So I have 1, 4, and 8. Are there any common factors there?
T.
Well, just from the numbers first.
1.
So we could take out a 1, right? 1 would be the only number they have in common. But since it's just 1, we don't have to factor it out, which means since there's nothing to factor from 1, 4, and 8, we move on to the variables. So you have t to the 4th, t, and t squared. So the greatest common factor is going to be the variable with the smallest power. So which one is that going to be?
T.
T.
4T.
Good. Just t, right? 1t. So we take that t out, and I'm taking a t from all of these, right? So what is t factored from t to the 4th going to give me?
T to the 3rd.
Good. And t from 4t, negative 4t?
Negative 4.
Good. Plus t from 8t squared, what am I going to get?
Negative 8 or 8T.
8t. 8t. There you go. That's good. Now, I think my math lab will be cool with you writing it like that, but if you want to be proper, you can put everything from highest power to lowest power. So you could rewrite it as t cubed plus 8t minus 4. Just going from highest power to lowest power to constant. So this is also an answer as well. Just depends how proper you want to be. Or if my math lab will make you type it like that. Okay, cool. Let's keep going. All right, look at that. 8m squared n cubed minus 24m squared n squared plus 4m cubed n. So again, look at your numbers first. 8, 24, and 4. What could we take out?
4.
4. Good. Let's see if we can get this all in one go. Now look at your variables. M squared, and cubed. What is the largest power of m that I could take out?
M squared.
M squared. And then n cubed, n squared, and n. What's the largest power of n that I could factor out?
N.
Just in.
Just n. Good. Here we go. So now our greatest common factor is 4m squared n. So when I take 4m squared n from 8m squared n cubed, what do I have left over?
2N squared.
2N squared.
2n squared. Good. Minus, and now you're taking it from 24m squared n squared. What am I left with?
6N.
6n. Plus, and now you're taking it from 4m cubed n. What are we left with?
M.
Just m. There you go. Nothing else we could do there. All right. Everybody good?
Yes, sir.
Okay. Keep going. All right. 5. Let's do it again. I have 100 and I have 16. What's the biggest number I could take out of there?
25 or 4.
4, right? I can take a 4 out from those numbers. And then I have a to the 5th and a squared. What's the largest power I could take out?
8 to the 2nd.
Good. And then b cubed and b, what could I take out?
B.
B. Good. And now 4a squared b from 100 a to the 5th b cubed. What's 4 factored from 100?
25.
25. A squared from a to the 5th. I guess the trick could be just subtract them.
A3.
That's it. A to the 3rd, a cubed. And then b from b cubed.
B squared.
There you go. Plus, and now we do it again. 4a squared b from 16a squared b. Well, 4 factored from 16 leaves me with
4.
4. And then a squared b from a squared b.
Nada.
That's it. There you go. They just cancel. There we go. Okay. Sweet. Okay. What's left? Those. Okay. Perfect. All right. Let's do it again. 42, 14, 7. What's the common factor there?
7.
7. P cubed, p to the 4th.
P.
P. Good. Q squared, q squared, q to the 4th. What's our factor there?
Q squared.
Q squared. Good. Now factor it from all the terms, and when we take it from 42p cubed q squared, what are we left with?
6p squared.
6p squared. Plus, now take it from 14pq squared, what are we left with?
2.
Just 2. Minus, now take that from 7p to the 4th, q to the 4th, and what are we left with?
7p cubed.
Well, the 7s will cancel, right? Because we're taking 7 from 7.
Oh, that's correct. Yeah.
But p from p to the 4th is p
cubed, q squared.
and then q squared. There we go.
Negative 7. 7. 7
I'm sorry I'm late. What chapter is this that we're doing right now?
This is factoring strategies. So this is before we enter chapter 2. I'll post the notes in here. Let's see. Where are they? There we go. Factoring strategies. There. I posted the notes in the chat. Okay. Let's do it again. So we have, if we look at the numbers, so again, I'll put a 1 in front. And you have 1, 2, 3, 4. So between those, their only common factor is 1. And then we can move on to the t's. I have t to the 5th, t cubed, t to the fourth, and t squared. What's the highest power of t I could factor out?
5.
I guess I could say lowest power. What's the lowest power of t?
T squared.
T squared. And then we look at our r's. There's no r here, but you have an r here. There's no r there, but we have an r there, which means we cannot factor out an r. So our only common factor here is just t squared. So now, if I take t squared from t to the fifth, what are we left with?
T cubed.
T cubed plus t squared from 2rt cubed, what are we left with?
Two RT squared.
Just 2rt,
2 RT, I'm sorry.
right? Minus t squared from 3t to the fourth, what are we left with?
3T squared.
3t squared plus t squared from 4r squared t squared leaves us with
4R squared T. 4.
just 4r squared, right? Because your t squareds will cancel.
Oh, yeah, that's right. I'm sorry.
You're good.
4R2
It's a lot of letters to look at.
T3 4R squared.
There you go. And there's nothing else we can do on that one. Okay. All right. 8, an easy one. Yeehaw. Hopefully it's easy. Look at the numbers first. -15 and -30. What's the common factor?
15.
15. Let's go ahead and make it -15 though. Since they're both negative, we can take out a common factor of -15. And then for p cubed and p squared, what's the common factor there?
T squared.
P squared. There we go. And now take -15p squared from -15p cubed. What are we going to be left with?
P.
Just p. Plus, because negative from negative makes positive, what's -15 factored from 30?
+2.
That's it, +2. Because your p squareds will what?
Cancel.
Cancel. There it is. All right, let's do it. All right, 9. All right. So again, we look for things that are common and we look at the numbers first. So here's a 7. And again, I can put a 1 in front and there's a 1. So there's no common factor there other than 1, which means we move on to the next variable and we see there's a y here. Oops, other color. There's a y here, but no y there, which means we can't factor out a y, which means we look at the next term and here you have an x squared plus 1 and there you have an x squared plus 1. Do those look common? They look the same, right? Yeah, they look the same. So our common factor here is just x squared plus 1. So we take that out, and what's left over? If you take x squared plus 1 from 7x squared plus 1, what's left over?
7.
7. Minus, and if you take x squared plus 1 from yx squared plus 1, well, negative yx squared plus 1, what's left over?
-1.
There you go. That's it. All right. So that finishes the factoring by just the greatest common factor. Any questions on that page? I have to, one moment. Okay, cool. So next up is factoring by grouping. So if we're ever given a four-term polynomial and we're asked to factor it, the only way to factor a four-term polynomial is by grouping. So you would look for a greatest common factor first. If there is none, then what you're going to do is group two terms together. So if I use this example, I'll use this example below. So if there's no greatest common factor, then you would move on and you would group the first two terms, and then you would group the last two terms and find a common factor in those separately. And then from there, we should be able to factor in more. So let's try it out. And like I said, always look for greatest common factor first. And we see there's some numbers here, but here I have A, B, 3, 3. Nothing's coming from there. I have an X, an A, a B. So for this four-term polynomial, we see from the beginning, there's no greatest common factor, which means we can move forward to factor by grouping. So to factor by grouping, like I said, group the first two terms, group the last terms, and now look for a greatest common factor in both. So for AX and BX, what's my greatest common factor in that one?
X.
X. So I take an X out, and that'll leave me with A plus B. Good with that?
Okay.
And then look at 3A and 3B, and what's my greatest common factor there?
3.
3. And it's a positive 3 at that. So if I take out the 3, I'm left with A plus B. Okay, we good so far? So all of this is we're still factoring. So once you factor that by grouping, the next step is we're still factoring and we're looking for a common factor. Well, what looks common on this line?
A plus B.
A plus B. There's your common factor, which means we will factor it out. And what is left over?
X.
Plus. Because remember, we're still doing the same process as the last page. You take A plus B from X times A plus B, and that just leaves us with X. And then you take A plus B from 3 times A plus B, and what's that leave us with?
3.
3. And there it is. That's it. Factored. Any questions on that one?
Looks really familiar now that I'm like looking at it. So that's good.
Good. Okay. And again, you can always check your work. Just FOIL it back out. So you can check just to make sure you did it right. You don't have to do it all the time, but just check. If you FOIL, I'll get a times x plus 3 times a plus b times x plus 3 times b. It's the same as that, just ordered differently. You have the same exact terms. Okay. So it doesn't hurt to check to make sure you did it right. Okay, let's do it again. So here, let's just focus on grouping. Let's not worry about the greatest common factor unless we actually see one. So here we have a 4-term polynomial again. So right off the bat, I'm just going to group these two, and I'm going to group the last two, including that negative sign. So now look at 2x plus 6, and what's your greatest common factor there?
2.
2. So if I take a 2 out, just from this term, what does that leave me with inside?
X plus 3.
X plus 3. Good. And now, look at negative x squared minus 3x. What's our greatest common factor there?
X.
X. But we're going to have to make it,
Positive.
well, negative.
Both negative.
Because if we take out a negative, this means everything inside is going to be positive. So if you take negative x from negative x squared, well, negative from negative makes positive, and x from x squared just leaves me with what?
X.
X. Good.
So is that a rule?
Yes.
Okay.
So remember, we can always take out a negative, because if you took out a positive x, this would now be negative x,
Yeah.
and we don't want that.
That makes sense.
Yeah.
Okay.
But I mean, it's all trial and error. How do you know? Well, try it out, see if it works. If not, then take out the negative as well. Which means now, if you factor negative x from negative 3x, what are we going to be left with?
3.
3. There you go. And now, what looks common?
X plus 3.
X plus 3. Factor that out. And what is left over?
2 minus X.
2 minus x. You got it. That's it. All right. Any questions on that one? All right. Let's do it again. 5x plus 15 plus xy plus 3y. 4-term polynomial, so automatically let's just group them. Group those two, group the last two, including the sign. And from 5x plus 15, what's my greatest common factor there?
5.
5. And factor that out, what are we left with inside the parentheses?
X plus 3.
Good. And then on xy, 3y, what's my greatest common factor there?
Y.
Good. And we're going to take out a positive y, right? And what will that leave me with?
X plus 3.
There you go. And now what looks common?
X plus 3.
Your x plus 3s, you factor that out, and what is left?
380. 5 plus y.
5 plus y. There you go. Not bad. Okay. All right. Again. Group these two. Group those last two, including the sign. And this looks familiar. From 2x minus 6, what could I take out? What's my factor there? Just
I would say no factor, right?
on 2 and 6.
Oh,
You could
two.
do the 2, which would leave you with x minus
6.
3.
Okay.
And then negative xy and positive 3y, what's our greatest common factor there?
Y.
Y. But we're going to have to make it what again?
Negative y.
Negative y. And if I take negative y from those terms, what am I left with?
X minus 3.
That's it. And now that's common. You take out the x minus 3, you factor it out, and what's left over?
2 minus y.
Done. All right. Cool. All right. So that finishes that page. Any questions on those 4? Okay. Let's do it again. All right. So just group these and group those. And on 2x plus 1, are there any factors there? So
Nope.
the only thing between 2 and 1 is a 1, right? Everything has a common factor of 1. So that's all we can actually take out from here. So the way I'm going to write this is just 1 times 2x plus 1. But then on 4xy plus 2y, what could we take out there?
2y.
2y. And what would that leave me with?
2x.
2x plus. So
1.
when you, good. 2y from 2y, because remember it's essentially dividing. Anything divided by itself is going to give us 1. And now we see that these are common. Factor it out. And what is left over? Don't forget the
2y.
1 plus 2y. There we go.
That one in front of those parentheses really bothers me. I don't know.
Yeah, I mean, I could leave it off, but just understand that no matter what, there's always a 1 in front unless there's another number there.
Gotcha. Okay.
So
Is
the
the-
reason I put it there is so you can see it factored here.
Is the My Math Lab, will it accept 2x plus 1, 1 plus 2y, and like 1x or 1 plus 2x and 2y plus?
So if you wrote these differently, like 1 plus 2x and 2y plus 1,
Exactly.
yeah, it would accept it still. You could also rewrite it as 1 plus 2y and 2x plus 1, and that's still an acceptable answer.
Cool.
Yeah. Or. Okay, good question. All right, again, 3j squared k and 15k, and then j squared plus 5. All right, so from 3j squared k and 15k, what can we take from the 3? What's the biggest we can take from 3 and 15?
3k.
3 and a k, right? So we take a 3, and since there's a k there, we take a 3k out, and what are we left with?
J squared
Okay. Plus,
plus 5.
there you go. And then j squared plus 5. Do you see any common factors there?
Just 1.
Just a 1. So if you don't see anything else, you can always take out a 1. And that'll be j squared plus 5. And common, factor that out. And what's left over?
3k plus 1.
3k plus 1. Good.
Professor, if j squared was negative and 5 was still positive, would you use? Does it matter which way you write it? You know, like -1 or negative j squared, or
Yeah, so that would be a big difference. Like, let's say that it was negative j squared plus 5.
Mhm.
Then if you took out a -1, you'd get j squared minus 5.
And should you preferably make the non-letter number negative, or?
Well, yeah, I mean, when you factor out that negative, the 5 has to turn negative. But if the
Plus.
problem was negative j squared minus 5, and you took the -1 out, then you'd get j squared plus 5, which would match up. So let's say we were in this situation, and this didn't match up with that one. This means we couldn't factor it at all. We would move
But
on.
could you do 1 and keep the j negative?
Yeah, you could.
Okay.
So I could take a 1 out, and it would still be negative j squared plus 5.
Cool.
So factoring a 1 out doesn't change anything. It just puts a 1 out in front.
But if you don't put the 1 out in front, you get the problem wrong. Like because I was thinking, before you put the 1, I was thinking, well, you got 2 likes, j squared plus 5. If you just bring the j squared plus 5 down, put it in parentheses, that just changes the whole answer.
Exactly. Yeah, because the reason I put the 1 there is, I mean, it's for good reference, so you know that the 1 still exists. Because if you don't have that 1 there, then you could make the mistake of writing this as your answer, j squared plus 5 just times 3k, which would definitely be incorrect, because if you distribute it, you are not going to get the original problem back. So definitely that 1 needs to be there. So again, if you don't know if you did it right, again, just check it, foil it, and see if you get the original answer up top. I mean, the original problem up top.
Mhm.
That's the best way to check, is just to undo your work. Okay, again, just group, and look at the first group, 2ab squared minus 6ac. What is our greatest common factor?
2a.
2a, good. If I factor that out, what am I left with?
B squared minus 3c.
Very good. B squared minus 3c. Hey, and look, we come up to another situation here. B squared minus 3c. There any factors there that are common?
None.
None.
Well, one.
So
So +1.
that's it.
Yay.
So if you see no common factors, then you can always take out that 1. Okay, common, factor it out. And we are left with, what's left over?
2a plus 1.
+1.
There you go. Perfect. All right, number 8. Group them. And first one, 14w to the 6th x to the 6th plus 7w x w to the 6th. What is my common factor for these terms?
7w6.
Good. 7w to the 6th. And factor it out. What are we left with?
2x6 plus 1.
X6.
Good. Plus 1. And now, negative 2x to the 6th minus 1.
It's the +1 because we had already factored out that whole thing.
Good. It's a plus 1, but in this case, we have to make it
I was
negative.
talking about the other one. I'm sorry.
Oh, that one, yeah.
Like on the first part, like
Yeah.
that +1,
Yeah.
that's because we factored it out.
From itself.
Gotcha. Okay.
Good.
And then on this second one,
You take out
Yeah,
the negative
just that.
1, and it makes everything positive. There we go. Common. Factor it out. And what's left over? Good. 7w to the 6 minus 1.
Is it just easier to do the negative? Or I'm so confused why you
For this-
switched it.
For this part,
Mm-hmm.
so the reason I took out the negative is so I can make everything in here positive, because everything above was already negative. So remember that if we're factoring by grouping, these two parentheses have to match. So if I just took out a 1,
Mm-hmm.
that means everything in here would be negative and would not match this one.
Gotcha.
So
And the
So-
reason you did -1 is because between -2x 6 minus 1, the only like terms is -1.
Exactly. The only common factor would be
Only
negative
common
1.
factor is -1. Yeah.
Yeah. I mean, it can have a common factor of 1, but now it would just make sense to take out a -1, so you change all those signs. So 1's a crazy number. Okay. All right. 9. Group them. Let's do it. Group. And for 18p to the 4th x minus 4x, what's our common factor there?
2x.
2x. Good. What do I have left over?
9p4.
Good. Minus
2x.
just
Just
Or
2.
2. There you go.
Okay. Okay.
And now negative 9p fifth plus 2p. What's my common factor there?
-p.
Very good. Negative p. And what's that going to leave me with?
9p4 minus 2.
There you go.
On that one, why would you go with the negative p instead of just p?
Good. So again, if we just took out p, which would not be wrong at all, right? The 9 would still be negative and the 2 would be positive. Which again, would not match up with this one. So you wouldn't be wrong by taking out a positive p, but that means you would just have one more step to take out the negative
I would
1.
have to switch it around. Okay. I think I get
Yeah.
this.
Yeah.
Okay, it's all looking familiar. Thank you. I'm sorry, guys. I'm asking so
No.
many questions.
You're good. They're good questions. And then common, take it out. 9p to the 4th minus 2. And what's left over?
2x
2.
minus p.
Good.
Yeah.
There you go.
If I were to take like the extra steps
That would-
without realizing it, are you going to penalize me for
No,
that?
if you need that extra step, go. I mean, if you need it, do it. Why not? Because you guys are learning factoring by grouping. Because I don't know how far 0410 taught you or how long it's been since you factored, but yeah, however many steps you
That's the
need.
last time I remember this. And
Yeah,
so I
because
need
let's
this
say
refresher.
you did take out just a positive p, then that'd be negative 9p to the 4th plus 2. And then your next step would have to be taking out the negative 1, which would make it negative p, meaning that'd be 9p to the 4th minus 2, which would then lead you back there.
Okay.
So if you needed those extra steps, then do it.
Cool beans. Thank you.
Mm-hmm. Okay, cool. So that finishes factoring by grouping. All right. So we've done factoring by the greatest common factor. We've done factoring by grouping. Next, we'll get into factoring trinomials. But any questions on this page? Okay. All right. Next up is factoring trinomials when the leading coefficient is 1. Since we're covering a lot of content, go ahead and let's take like a small 3-minute break I'm gonna go refill my water bottle and let's get back at it. Okay, let's do this. So factoring trinomials when a equals 1, there's a lot of stuff on this page. So I'm not going to read all of it. I'm just going to walk you through it on the next page. So let's get started on these problems already. Okay. So we are factoring trinomials where the leading coefficient is 1. That's when it says when a equals 1. So here you have the leading term of 1. Now for trinomials, these are the easiest ones to factor because in order to factor these, all you have to know are the factors of the last number that could possibly add or subtract to make the middle number. So I'm trying to put this as simplest terms as possible because factoring should be easy as that, not having a whole page of definition on how to actually factor. Okay. So when we factor these, like I said, all you have to do is worry about all the factors of the constant, the final number. And here our constant is 45. So I'm going to make a little chart here and run down all the factors of 45, starting with 1 and 45. 2 doesn't go. 3 goes. 3 and 15. 4 doesn't go, 5 goes, 5 and 9, and I think that's it other than repeating the ones we have. Okay. And if you need help listing factors, well, you're on your computer. You can go to Google and be like, Google, tell me all the factors of 45, or whip out a multiplication chart. So now, from this point, what we want to ask ourselves is, out of these factors, which ones, when you add or subtract them, can give you positive 4?
5, 9.
Definitely 5 and 9, right? 5 and 9 is the obvious choice here. And when I say add or subtract, well, let's look at your factors. 1 plus 45 can give me 46, or 45 minus 1 can give me 44. Are those anywhere near 4?
No, sure.
Definitely not. 3 and 15, if I add those, I get 18, and 15 minus 3 gives me 12. I don't get anywhere near 4. This is why 5 and 9 are the best choice. Okay. All right. So now when we factor it, well, there's other things we have to know here. First thing we're going to do is set up our parentheses. I'm going to have x here and x there, because when we FOIL, x times x gives me x squared. Okay. And now we have to input 5 and 9 into these parentheses with appropriate signs. So how could you write 9 and 5 to give you 4? Which number is going to be negative?
-5.
Good. So 9 minus 5 would give me a positive 4. This means when I input the numbers into the parentheses, I'm going to make this x plus 9 and x minus 5. Just as I have written them there. I have a positive 9 and I have a negative 5. And guess what, guys? It's factored. That's it.
That's it. Yeah.
That's it. That's it.
Does the order doesn't matter, right?
The order does not matter. You can write it also as x minus 5 times x plus 9. Just make sure your signs are the same on both numbers. Again, and now you want to know if you did it right. FOIL it back out. X times x, x squared. X times negative 5, negative 5x plus 9x minus 45. And you get x squared plus 4x minus 45. Does that look like the original problem? So we did it, guys. We did it. And that's how you factor. Oops. Or, okay. Now, before we move on, I'm just going to make a little sign chart here that'll help us determine what signs to pick for our trinomials. So if we're ever given, I'll call this our sign chart. I'm pretty sure I have it on the next page, but I'll write it here. If you're ever given x squared plus bx plus c, then you're going to have plus plus. If you're ever given x squared minus bx plus c, then your parentheses will be minus minus. And then if you're given x squared minus bx minus c, you're going to be plus minus, or you'll be minus plus. And then last form, if you're given plus minus, well, it's going to be the same as above. You're either going to be plus minus or minus plus. Now this sign chart holds true for all the trinomials because look what we just did. We were given plus minus on this one. And since it was plus minus, we ended up being plus minus, or with the other answer, minus plus. So you see how that works out? So that is the sign chart survival guide for these trinomials. It helps out a lot. Okay, let's try it again. W squared minus 15W plus 50. Okay, so again, like I said, just worry about the last number. And for 50, we will list all the factors of 50 that could possibly make 15. 1 and 50, 2 and 25, 3 no, 4 no, 5 yes, 5 and 10, and I think that's it. Okay, now look at these factors and which ones can add or subtract to give you 15.
5 and 10.
5 and 10. And how would you write 5 and 10 to give you negative 15?
Okay.
Negative 5 minus 10 gives you negative 15, right? Now, if we were to apply my sign chart survival guide, here you have minus plus. Up here, minus plus means you get minus minus. So that's how you would set up your parentheses. So just double verification on how to set them up. So that means here, I can write bigger, we'll have x minus a number, x minus a number, and in those parentheses is going to be 5 and 10, and that's it. I put x's. They should be w's, but
Right.
whatever. I'll change it. There you go. Any questions on that so far? Okay. Let's keep moving. All right. Z squared minus 16z plus 48. Again, just have to make an XY chart. Well, not an XY chart, just a chart for all the factors of 48 that can possibly make 16. So 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5, no, 6, yes, 6 and 8. And I think that's all our factors. So which of these factors can get us to 16?
-4, -12.
Good. 4 and 12. -4 minus 12 gives me that -16. And by our sign chart survival guide, that's minus plus, which means again, we're going to have minus minus as shown there. Look at that, minus minus. So when I set this up, you'll have z minus 4 and z minus 12, and that's it. Factoring couldn't be any easier, right? Okay. Ooh. Now we're getting there. Okay. So now we have negative 40t, negative 30t squared, and 10t cubed. Well, when you factor a trinomial, we only are used to factoring in the form of squared, meaning the highest power is always 2, which means that for problem number 4, we have to fix this by finding a greatest common factor. So here's where all your factoring rules come to work together. So if you look at this, 40, 30, and 10, what's the biggest number you could take out?
10.
10. So let's take a 10 out. And then you look at t, t squared, t cubed. What's the biggest power of t you could take out? Or the smallest?
T.
Just a t. Okay. So if I factor that out, what am I left with?
Negative.
-4,
There you go. -4 minus
3t,
3t plus
1t3.
1t squared, right? Okay. Well, now we get the square that we want, which means that we want to factor the inside trinomial, but I'm going to have to rewrite it first. So now I'm going to rewrite this as 10t times, and I'm just going to rewrite the inside as highest power to lowest power. So you'll get t squared minus 3t minus 4. So all I did was rearrange it from highest power to lowest power to constant. And if you're wondering what a constant is, because I've been saying it all day, a constant is just a number without a variable. Okay. So now we are ready to factor the inside trinomial, where all we have to do is list the factors of 4. 1 and 4, 2 and 2. Which of these factors can get us to -3?
-4 and 1.
Good. So we're going to use these, and you said we can write it as -4 plus 1,
Yes, sir.
which will give us -3. Good. So now, when I set up my parentheses, do not forget about the 10t. He tags along the whole way. I'm going to get t minus 4 and t plus 1. And that is it.
What you said, 15.
Don't forget about that 10, that 10t. It's part of the answer the whole way. All right. Good on that one. All right. Let's go. Let's go. Let's go. Okay. Number 5. Just like the last one, we're going to have to rearrange it. So this is negative 5w plus w squared minus 6. We need to put it in the proper form to be factored. So all we have to do is just rewrite it with the highest power first. So we just rewrite it as w squared minus 5w minus 6. So now it's in its proper form, which means we can go ahead and factor it. List all the factors of 6 that could make 5. 1 and 6, 2 and 3. Uh-oh. So both of these factors can give us 5, right?
Yeah.
But that means that we should now reference our sign survival chart. So that'll help us out with the actual factors we can pick. If we have minus minus, that means I'm going to have, so if we go back here, if we have minus minus, this means we can set up as plus minus or minus plus. And that's going to help us determine which factors to pick. So let's just go with the first setup of plus minus. So go back to that page. Oops. Where we go? Dun, 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 dun. There we go. So w squared minus 5w, when I factor this, we're going to get w plus a number and w minus a number. That means one of these have to be added and subtracted. So no matter what, this will cancel out which factors to use.
2 and 3.
2 and 3, right? Because one has to be positive and one has to be negative. So if you did 2 minus 3, you'd get negative 1. Or if you did 3 minus 2, you'd get 1, which means based on our sign chart, we are going to choose 1 and 6. So that's where your sign chart can come in handy. So 1 and 6 is going to work out. And since, here's another way I also like to teach factoring. Instead of having to write them out with the signs all the time, is I say if 1 and 6 can give us negative 5, this means the bigger number must be what?
First. It goes first.
Well, the bigger number must be
Last.
negative. And the smallest number must be positive. So just another play on words and factoring. So again, I said, if our factors are 1 and 6 and we get a negative 5, this means the bigger number of 1 and 6 must be negative. Maybe that takes a little bit of thinking, but it's a fun way to say it. Other than that, you would write it out as negative 6 plus 1, which would give you negative 5. Okay. We're moving. All right. 6. Negative a squared plus 6a minus 8. Okay. I hate to factor when the leading term is negative. So here we have a negative 1 in front. So all we're going to do for this one, in order to change it into a positive a squared, is factor out what number?
Negative 1.
Negative
You
1.
got a negative 1. If I factor out a negative 1, that's going to make that a positive a squared, a negative 6a, and a positive 8. You can factor it in this form, but I just hate it. I don't like that leading term being negative. It just isn't right. So take out that -1 and we get the right form that we need, which means we can list all the factors of 8, 1 and 8, 2 and 4. And now, which ones are going to get me to -6?
2 and 4.
2 and 4. All right. And if you access your sign chart, if you want, this is going to factor to a minus a number, a minus a number. You see how that's minus plus. And all we have to do is fit 2 and 4 in there. And guess what? Done. Okay, awesome. Oof. All right, 7. -2c squared plus 22cd minus 60d squared. Well, now hopefully your greatest common factor brain is going off now, and you see that there is a greatest common factor of what?
2.
2. But we're going to make it
-2.
-2, which means when I factor that out, what am I left with?
C squared
Plus
plus 11C D
11cd,
plus 40D squared.
smaller.
30, I'm sorry.
There you go. 30d squared. There we go. And now we get the quadratic that we need. We get the trinomial that has a power of 2 and it's positive. So that means all we have to do is list the factors of the last number. And you get 1 and 30, 2 and 15, 3 and 10, 4 no, 5 yes, and I think that's it. So which of these factors is going to get us to 11?
5 and 6.
5 and 6. And look at that. It's plus plus. Those are my favorite because they're the easiest, right? You get, don't forget that -2. He stays out there. And this means you're going to get C plus 5D times C plus 6D. And there you go. This time we had to add that variable of D on because of that D squared up there. All right. All good?
Yes, sir.
All right. Okay, number 8. Let's do it. -3a squared plus 15ab minus 12b squared. Look at that again. You have -3, you have 15, and you have 12. What's our common factor there?
-3.
-3.
-3. That'll leave me with a squared minus 5ab plus 4b squared. Okay. And now you can list the factors of 4, 1 and 4, 2 and 2, and which ones are going to get us to 5.
4 and 1.
1 and 4. And look, minus plus, that's another one of my favorite forms because those are easy. That means that we're going to have minus minus. Don't forget that -3. And you'll have a minus number, a minus number, and what numbers are going in there?
-4 and -1.
Good. And don't forget to add the b because of that b squared there. You don't need to write it as 1b. You can just write it as b. But if you need that one there, that's totally fine. Okay. Yuck, get uglier and uglier. All right. T to the fourth u squared plus 6t cubed u squared plus 9t squared u squared. Woof. Let's look for a common factor. T to the fourth, t cubed, t squared. What could we take out?
T squared and U squared.
Good. T squared and u squared. And now, what would that leave me with inside?
T squared plus 6 squared, or 6t.
Plus the 9. Okay. Which means, again, the inside trinomial is in the form that we need. The power is 2. The leading coefficient is positive. It's a positive 1. And all we have to do is list the factors of 9. 1 and 9, 3 and 3. Who's getting us to 6?
3 and 3.
3 and 3. Bring these down. T squared, u squared, and this is plus plus. These are my favorite because that means you'll get t plus a number, t plus a number, and we said 3 and 3 are going to work. So just put 3 there, and it's done. All right. And that is where we will stop today. We covered some good ground.